Hi, welcome to Python Polygon. So today we'll be covering the next chapter, time, speed, distance, train, boats and stream. It's a very lengthy chapter name, but it's actually very simple, okay? What you need to know is, again I recommend you finish the second and third chapter first because it's all in a chronological order. So if you skip the previous parts, I don't think you might follow. Okay, so in the second and third parts, we spoke about flow and rate, okay? Here we talk about time, speed, and distance. Okay, so if you build an analogy, you can think about distance as work done and speed as the rate of doing work. Okay, and time remains the same. Okay, similarly, in trains also the same thing, speed and distance is there, and boats and streams also same thing is there. Okay, so in the beginning you have a few facts that speed is distance by time, average speed is total distance by total time. If you want to convert kilometer per hour into meter per second, it is kilometer per hour into meter per second. Then you have 1 kilometer is 1000 meters, and this is how we convert it basically. And 1 hour is 60 minutes. Okay, and then again, this is 1000 meter, and this is 3600 seconds. Okay, so you have a multiplication factor of 1000 by 3600 into meter per second. Okay, so this is how it works. So if you forget about this 5 by 18, if you cancel this into its lowest forms, you'll get 5 by 18. If you forget this number, you can do it in the big method. Okay, so kilometer you change to 1000, and then hour you change to seconds. Okay, this is how it's done. Fine. In rate and work, we saw that, and even in that flow, pipes and flow, we saw that if there are two opposing actions, we have to always subtract their rates. Okay. So here, rate is nothing but speed. So we subtract the speeds. If they're going upstream, basically the stream is going down and the boat is going up. So this is called upstream. And downstream is stream is going down and boat is going down. So this is b plus s and b minus s. Okay. Speed of boat in still water is 0.5 into d plus u. We don't use this actually. Rate of the stream is that also we don't need. Okay, let's go with the questions. So the first question, again, the notebook is shared. You can go to the Google Drive link in the description and take this notebook so you can refer. Fine. First question, Samuel covers the distance from his home to his office at a speed of 25 km per hour, comes back at a speed of 4 km per hour. The complete journey, uh, he completes the journey in 5 hours and 48 minutes. Find the distance from his office to the work. Okay, so to home, I mean. So let's assume this is his home, this is his office, and the distance between his home and office is d. Okay, so at in the beginning, see, we use one simple formula again and again. Speed is equal to distance by time. Okay, on the first trip, his speed was 25 km per hour. Okay, so 25 km per hour is equal to distance divided by time. Okay, so distance. So we'll find time 1. Okay, t1, that is while going it took t1, while coming back it took t2, where his speed was 4 km per hour. Okay, so now we find out t1. T1 is equal to d by 25. Okay, in hours, and similarly T2 is equal to, see, again we use speed is equal to distance by time, where 4 is equal to, distance is constant d only, divided by time is T2. So T2 is equal to d by 4. Okay, this is T2. Now we also have that T1 plus T2 is the whole journey, right? And in the whole journey he took 5 hours and 48 minutes. So that is nothing but 5 hours plus 48 by 60 because it's in hours. Okay, these many minutes he took. Fine. So we substitute the values of t1 and t2. You get d by 4 plus d by 25 is equal to 5 plus 48 is 4 times, and this is 5 times. 5 plus 4 by 5. Okay. So if we take d common here, you get 29 by 100 if you take LCM, and then this comes as 29 by 5. This and this cancels. This 100 goes this side. So d is equal to 20 kilometer. Okay. So the distance from his home to office is 20 kilometer. This was simple. Next question. If John walks at a speed of 5 km per hour, he reaches his office 7 minutes late. If he walks at a speed of 6 km per hour, he reaches his office 5 minutes early. Okay, how far is his office from his house? So yeah, we'll call this his home and this his office. Okay, the distance is d. Okay, now let's assume his reporting time at the office is t. Okay, so t is his reporting time. Okay, now see, if he walks at a speed of 5 km per hour, okay, first we'll convert it into minutes because we are 7 minutes late. So to avoid any confusion, let's convert 5 km per hour into kilometer per minute. Okay, to do this we simply have to divide by 60 again. So it is 5 by 60 kilometer per minute. So this is the answer. Okay, that is 1 by 12 kilometer per minute. Okay, so if he walks at a speed of 1 by 12 kilometer per minute is equal to distance, okay, that is d, divided by the time. His reporting time is t, okay, but he reaches the office 7 minutes late. If he reaches 7 minutes late, that becomes t plus 7, the time he reaches at, okay. So we get that t plus 7 is equal to 12 into d. This is your first equation, okay. Secondly, if he walks at a speed of 6 km per hour, okay, he reaches the office 5 minutes early. Okay, if he reaches, see again 6 km per hour has to be converted into kilometer per minute. To do this, we divide by 60. So we get it as 1 by 10 kilometer per minute. Okay, so if he walks at a speed of 1 by 10 kilometer per minute, speed is equal to distance divided by time. Time is t. T is his reporting time. He reaches 5 minutes early. It becomes t minus 5. Okay, so we get t minus 5 is equal to 10 into d. Okay, now using these two equations, let's subtract this equation from this equation and then add both the equations. So we get 2d on this side is equal to t and t cancel. You get this as plus 5 plus 12. Okay, so d is equal to 6 kilometer. So his house and office have a distance of 6 kilometer. Fine. Next question. Rajdhani Express halts for 3 minutes every time it covers 75 kilometers. If the train runs at a speed of 100 km per hour and the destination is 600 kilometers away, find out the time taken to reach the destination from the source. Okay. So let's break this down into 75 kilometer splits. Okay. Let's see. To cover 600 kilometers, how many times he has to cover 75 kilometers? You have to find out. Okay, that is nothing but 600 divided by 75. So he has to cover 8 such splits. Okay, so now let's start from the first. In the first 75 kilometers, okay, every time he covers 75 kilometers, this is first, second, third, fourth, fifth, sixth, seventh, and eighth. See, for distance and time, try to draw as many diagrams as possible. So we have a diagram of the question, we can exactly picture how it works. Okay, so this is each interval is 75 kilometers. Okay, we have to find out how much time it takes. Okay, at the eighth end he reaches the destination. Okay, so first we need to find out at the end of how much time it takes to finish 75 kilometer. Okay, if he's going by 100 kilometer per hour, okay, then it how much time does it take? So basically 1 hour takes him, that is 60 minutes takes him. He covers 100 kilometers in 60 minutes. This is kilometer. So 75 kilometers, how much time it takes? It's a cross multiplication thing. So we multiply this and divide. You get 75 into 60 by 100. So this cancels 4 times, this cancels 3 times, this 15 times. So 45 minutes it takes. Okay. So this takes 45 minutes. Okay. Then he halts for 3 minutes. Then it takes 45 minutes. He halts for 3 minutes. Such ones are completed 7 different times. Okay, so it takes 7 into 45 plus 3 minutes to complete till here. Okay, till the last stretch. Okay, so that is nothing but 7 into 48 minutes, so that is nothing but 336 minutes. Okay, so 336 minutes are done till here. So the last stretch he doesn't have to wait the 3 minutes in the end, so we only add the 45 minutes of travel time. Okay, so 45 minutes he takes for traveling. This ends up, we end up with 381 minutes. Okay, till he reaches his destination. but the options are in hours. So we convert this into hours, divide by 60. So this becomes 6 full hours plus 21 minutes are left. So this is the answer, 6 hours and 21 minutes. Next question. Max completes his journey at an average speed of 9 km per hour. He covers the first 9 kilometers. Okay, so first 9 kilometers at a speed of 6 km per hour, and he takes 1.5 hours to complete the remaining distance. Okay, we'll call the distance x. So he takes 1.5 hours to complete this distance. Find out the speed in which he covered the remaining distance. So this speed we have to find out. Okay, so we know that average speed is 9 km per hour. So we'll call this distance x. Okay, so what is the total distance he traveled? It is 9 plus x. Okay. So the definition of average speed is equal to distance, total distance divided by total time. Okay. So that is nothing but t1 for this first and t2 for the second. Okay. Two splits are there. Okay. So to find t1, we can use the formula speed is equal to distance by time, where the speed is given to you as 6 km per hour and distance is 9. So time is equal to distance by speed clearly. So distance is 9, speed is 6, you get it as 1.5 hours. Okay. So he takes 1.5 hours for the first stretch and the second stretch. So then you get this as 9 is equal to 9 plus x by 1.5 plus 1.5, that is 3 hours. So this can, you can cross multiply. 27 is equal to 9 plus x. So x is equal to 18 kilometer. Okay. So if he covered 18 kilometer in 1.5 hours, okay, they want the speed. Speed is nothing but distance divided by time. So this is nothing but 18 by 3 into 2, 12 hours. Sorry, yeah, divided by 1.5, right? Yeah, 3, 6, 2, 12 kilometer per hour. So that's the speed he covered the last stretch at. Okay, fine. The next question. A train covers the journey of 4 stations connected to form squares to form a square at the speed of. So this is what it means. This speed is 20 km per hour, 40 km per hour, 60 km per hour, and 80 km per hour. What is the average speed of the train for this journey? Okay, so we consider the side length to be d because it's a square. It has equal side lengths. That's what they said. And see, average speed is defined as total distance by total time. Okay, this is average speed, right? So he started from here, ended at here. So the distance is 1, 2, 3, 4, 4d. Okay, 4d by t1 plus t2. We'll call this t1 time, t2, t3, and for this part he took t4, t3 plus t4. Okay, this is your answer. Now we have to find t1, t2, t3, t4. Okay, to do that, you have to take speed is equal to distance by time for everything. So time will be d by 20. Okay, similarly, t2 will be d by 40, t3 will be d by 60, and t4 will be d by 80. Okay, next you have average speed. We have to substitute everything into this formula. 4d by d by 20 plus d by 40 plus d by 60 plus d by 80. So d can cancel everywhere, and we are left with this common denominator becomes 240. So it will be 4 by 1 by 12 times. So 12 by 240 plus this is 6 times. So 6 by 240 plus this is 3 times, 4 times. 4 by 240 plus this is 3 times, 3 by 240. Okay, so we can take the same denominator and take it up. It will be 4 by 4 into 240 divided by 12 plus 6 is 18. 18 plus 4 is 22. 22 plus 3 is 25. So this is nothing but yeah, we cancelled 1 5 and this became 48 times. This goes 32 carry 3 16 192 by 5. 3 is a 15 and 38.4 is the answer. Okay, so his average speed was 38.4 in kilometer per hour. That's the answer. Simple. Okay, in a competition, Rahul is running at a speed of 50 km per hour. If he runs at a speed of 40 km per hour, then find the percentage decrease in his speed. Okay, we need to know the formula of percentage decrease. Always percentage decrease is nothing but the change, okay, divided by the old value into 100. Okay, so how much is the change? From 50 he went to 40. Okay, so this is nothing but 50 minus 40, the change, and the old speed is 50, and you have to do into 100. This is nothing but percentage change. So this and this cancels two times. This is 10, so it is 20% of change. Okay, there is a 20% decrease in his speed. 20% decrease in his speed. Seventh one. Ravi in still water can row a boat at 8 km per hour. He took thrice the time to row it than to row it down the stream. Okay, to row it up then down the stream. Find the current of the speed of the current. Okay, so basically this is upstream. Sorry, this is the opposing current is upstream. So this is the scenario of upstream where the stream velocity is going down and the boat is going up. Okay, and this is downstream where the stream and the boat are going both going down. Okay, so for this condition the speed will be speed of the boat minus speed of the stream. Okay, and for this condition the speed will be speed of the boat plus speed of the stream. Okay, this is what we discussed. So that is how you solve both questions. Okay, so in still water he can row the boat at 8 km per hour. So the speed of the boat is 8 km per hour. Okay, he took thrice as much time to row up than to row down. Okay, so let's find out the speed he takes to row up. Again we have speed is equal to distance by time. So speed is nothing but here to row up it is 8 minus the speed of the current, that is S, is equal to d by t1. Okay, so we'll find out the speed upstream. Speed upstream is equal to d by 8 minus S. Okay, and then similarly we have speed downstream is equal to distance by time downstream. Okay, speed downstream can be 8 plus S is equal to d by t downstream. So again you get t downstream is d by 8 plus S. Okay, now we need to find out, yeah, we've given a relation saying that it takes 3 times as much time to row up than down. So upstream time is equal to 3 into downstream time, because obviously the time he takes to go down is faster than up, so we have to do this. D by 8 minus S is equal to 3 into d by 8 plus S. Okay, we cross multiply, we get 8d plus sd is equal to 8 minus S into 3d. So you get 8d plus sd is equal to 24d. We can cancel d, that's what we see. We should have done it in this step. Okay, to find out the stream velocity, now we can simply substitute, we can simply solve this equation. We get 3 into 8 minus S is equal to 8 plus S. So we get 24 minus 3S is equal to 8 plus S. Take this side, take this side. You get 16 is equal to 4 into S. Stream velocity is therefore 4 km per hour. Okay. Now they're asking you find the, okay, that's what they asked you to find. So it's 4 km per hour. This was easy. Okay. Duronto Express with a speed of 105 km per hour starts from Prayagraj at 7. Okay, and reaches Orissa. There it stopped for 45 minutes. While returning back, the speed reduced by 20%. Okay, and it reached Prayagraj at 5:12. on the same day. Find the distance between Prayagraj and Orissa. So basically, from Prayagraj it reached Orissa, waited for 45 minutes, changed the speed and reached back Prayagraj at some time. Okay, we have to find out the distance. Okay, so let's say the distance is d. Okay, the speed is given as 105 kilometer per hour and starts at 7. Let's just calculate time for now. Okay, so speed is equal to distance by time. Distance is not given to you, but we'll call it as d. 105 kilometer per hour is equal to d by t. So time is equal to d by 105. Okay, so this is the time it takes for it to reach Orissa. Okay, and then after this time, this is okay. This is 105. Sorry. Yeah, after it reaches Orissa, it takes a 45-minute break. Okay, you add 45 minutes. That is nothing but 3/4 of an hour. So you add 3/4 of an hour. Okay, and then it travels back. So we calculate the time there also. Okay, here it reduced the speed by 20%. Okay, if 20% is the decrease in speed, we know the percentage is change divided by old, right? Old speed. This is the change. So 20 by 100 is equal to change. That is nothing but it decreased. So it is 105 kilometer minus the new speed divided by 105. Okay. So this can cancel 21 times and 20 times. And then we get 20 by 20 is 1. So 21 equal to 105 minus x. So x equal to, it decreased by 105, 84 kilometer per hour. Okay, so the speed on the way back is 84 kilometer per hour. So the time he takes is nothing but d by speed. So d by 84. Okay, now we need to analyze the whole situation here. First of all, we'll find out the complete time taken. He reached back at 5 o'clock and 12 minutes past 5 p.m. So from 7 to 12 there are how many hours? There are 5 hours. Okay, from 12 to 5 there are 5 hours again. Okay, and then there are 5 hours plus there's basically 10 hours plus 12 minutes. Okay, of travel time. Fine. So now we put together the equation. The first time he traveled from Prayagraj to Orissa, it took him d by 105 minutes, plus he waited for 45 minutes. We can't write it in minutes because we have to write it in hours. So we'll write it as 3 by 4 hours, plus he took d by 84 to go back. Okay, this whole ordeal took him 10 hours and 12 minutes. So that is nothing but 10 plus 12 minutes is 1/5 of an hour. Okay, this is the equation we need to solve. Okay, so we take 3 by 4 this side. So then we get d by 105 is equal to 10 plus 1 by 5 minus 3 by 4. So you get the answer of distance as 441 kilometers. Okay, between the two, between Prayagraj and Orissa. So that's the answer. Alright, the next question. A boatman takes 3 hours and 45 minutes to travel 15 kilometers downstream and takes 2 hours and 30 minutes to travel 5 kilometers upstream. Okay, what is the speed of the stream? So now this is simple two equation, two variables. Okay. Now see, we need to find out, one thing is the speed of the boat in Stila, but they want us to find speed of the stream. So we have to find s. Okay, b and s we need to find. Okay. Again, the same logic applies. When it's going upstream, then the relative speed is b minus s, and if it's going downstream, the speed is b plus s. Okay. Uh, First we calculate for downstream. Distance speed by time, mean distance speed is equal to distance by time. So the speed is nothing but b plus s is equal to, he took 15 he traveled 15 kilometers and took 3 plus 45 minutes. 45 minutes is 3/4 of an hour to do so. Okay, this is one equation, and the other equation is speed of upwards is equal to he traveled 5 kilometers in 2.5 hours. Okay, 5 kilometers in 2.5 hours. So that is nothing but 2 plus half. Okay, we need to find s here. If we add the two equations, s will cancel. So we do the opposite. We negate this whole equation and then we add it. So b will cancel. We need s. We are finding s only. Okay. So 2s is equal to 15 by. We'll take common denominator here. You get 12 plus 3, 15. So 15 by 15 into 4 plus, sorry, minus 5 by 5 into 2. Okay, so this cancels, this cancels. So 2 into speed of the stream. 2 into speed of the stream is 4 minus 2, that is nothing but 2. So speed of the stream is 1 kilometer per hour. Okay. Alright, next question. A train crosses the pole in 20 seconds. If the length of the train is 500 meter, what is the speed of the train? Okay, so we need to understand how a train crosses the pole at first. This is a pole, and let's say the train is just passing. Okay, so it's going to cross it now. Okay, and then once this is actually, see, it will be at the same point, but you won't understand, so I have taken the train a little behind the pole. Okay, this is the pole and this is the train. Okay, after this, after when it passes the pole, this will be the end of the train and this will be the starting of the train. Okay, so this whole distance will be the length of the train, correct? Now we need to know that how much the head of the train traveled. It traveled the length of the whole train, right? At the time it takes to cross the pole, the train traveled the distance L in meters, right? So whatever they've given, 500 meters. Okay. So what they mean is the speed of the train is equal to distance by time, and distance is nothing but length of the train. Length is 500 meter, that is 0.5 kilometer, divided by time is nothing but 20 seconds. Okay, so 20 seconds by 60 by 3600. So because you want the time in kilometer, oh, you want it in meter per second. Okay, so if it is in meter per second, you need 500 by 20. So it took 500 meter and it took 20 seconds to cover 500 meter. This is nothing but 25 meter per second. This is the speed of the train. Because at this moment, if you say time is 0, at this time it is t, the head of the train has covered the distance L, right? Because the length of the train is covered in the time t. So then we find the formula S is equal to t by t, where the distance is the length of the train, that is 500 meter by 20 seconds. So you get 25 meter per second. Okay, next question. A train is running at a speed of 100 km per hour. A car is running on the road parallel to the track at a speed of 20 km per hour in the same direction. How much time will it take to cross the car if the length of the train is 100 meters? Okay, see, whenever two bodies are traveling together, okay, to find out the length, to find out the speed of the, say, A and B are traveling together, okay, and to find out the relative speed, we always do A minus B, okay. So if you do the speed of A minus B, that means this becomes a scenario of the body A is moving with a speed of A minus B and the body B is at rest. Okay, this is how it will look. Fine. So that's what we do. We find relative speed of the train with respect to the car. That is nothing but speed of the train with respect to the car is speed of the train minus speed of the car. Okay. It is 100 km minus 20 km per hour. 80 km per hour. Okay. So this is the speed with respect to the car. Okay. Now the length of the car is negligible, so we'll assume it as the pole question only. Okay. So at the moment when the head of the car and the head of the train are at the same point, we consider time 0, okay, and when the train has completely covered the head of the car, this is when it will race the car, okay. So this is nothing but length of the train, okay. So here we can write speed, that is with respect to the train and the car, is equal to distance, that is the length of the train, divided by time, okay. Distance is nothing but 100, wait, distance is the length of the train, okay, length of the train is 100 meters. So this will be nothing but speed of the train with respect to the car is 80 kilometer per hour. But be careful, it is in kilometer per hour, but the length of the train is given as 100 meter, okay. So we have to convert this into meter per second. To convert it, we multiply by 5 by 18 is equal to 100 meter by time in seconds, okay. So here we can simplify, t will be 9 by 2, which is 4.5 seconds. Okay, so the train will race the car in four and a half seconds. Okay, it passes the car in 4.5 seconds. Next question. A train is running at a speed of 100 km per hour, and the car is running at on a parallel track at a speed of 20 km per hour opposite to the train. How much time will it take to cross the car if the length of the train is 100 meter? Okay. See, again, here we need to analyze the situation. The train is running this side, the car is running this side, okay. This is when the two heads are meeting. So this is the whole train and this is the small car, okay, and this is time 0, and then the time t will be when the tail of the train will race the head of the car, okay. This will be the time t, okay. We need to find this t. Here relative speed of the train, so relative speed of the train with respect to the car will be speed of the train plus speed of the car, because they are in opposite directions, okay. So the train will appear way faster than what it is, okay. So the train is 100 km per hour plus car is 20 km per hour, so this is 120 km per hour, okay. Again we have the equation, speed is equal to distance by time. Speed is 120 kilometer per hour, but it is into 5 by 18 meter per second is equal to 100 by t seconds that it takes to overtake the car. And here we can simplify. So you get t is equal to 3 seconds. Okay. Last question. What is the length of the platform if a train running at the speed 90 meter per second and the length is 80 meter crosses the platform in 2 seconds? Okay. So here it is an extension of the pole question, where the pole also has a length. That is nothing but the platform. Okay. So we need to analyze the situation. A train is running. Okay. This is the starting of the platform. Okay. Let's say the platform length is some L, okay, and the train length is LT, okay. So this is time 0 when the head of the train and the platform just meet, okay, and then when it takes, if this is the length of the train LT and the end of the platform, that is L, this is the scenario when the train is completely crossed the platform, okay. So this is the setup for this thing where the length is L plus LT, okay, and this is done in t seconds. Fine, this is what we have to find out. So the whole, we'll consider the length of the platform as x, okay, or L, we'll just keep it as L, okay. So here we use the formula, speed is equal to distance by time, same formula. Speed is what, 90 meter per second, so 90 meter per second is equal to distance is length of the train, that is nothing but it's given as 80 meter, okay, 80 meter plus length of the platform divided by 2 seconds, okay. So you get that 180 is equal to, if you cross multiply, 180 equal to 80 plus length of platform. We get length of platform is 100 meters. So this is the answer. By this we come to the end of this topic. Uh, I guess this is pretty easy once we have done rate and work and the pipe and flow thing. Okay. Thank you for watching. I'll see you in the next chapter.